before we multiply and divide rational expressions, we first need to be able to simplify them into their smallest terms. So a rational expression, again, is just means a fraction, is in simplest form if its numerator and denominator don't have any common factors other than 1, because if they had common factors, they would reduce or cancel out. So to simplify a rational expression, we can apply this property down here in the key concept box. So what we need to know is that we're canceling factors. Factors are things that multiply together. So in this first example, it says A, B, and C are just your numbers here, and B and C aren't 0 because they're in the denominator. If you have A times C over B times C in your fraction, the C and C, top and bottom, cancel each other out. So what you're left with is just A over B. C divided by C is really just 1, and it cancels out. So in the example below, 15 over 65, they factored that into their lowest terms, the prime factors of 15 and 65. So 15 would be 3 times 5, and 65 is 13 times 5. So since both of those numbers include that common factor of 5, they cancel out because that's really 1, and you're just left with 3 over 13. Now, if we're looking at expressions with variables in them, so we have 4 times x plus 3, and then on the bottom, x minus 5 times x plus 3. The x plus 3's are the same. So x plus 3 over x plus 3 is 1. It cancels out, and you're just left with 4 over x minus 5. So we just need to make sure that they're exactly the same and that they are factors. Because down below, that's what this is talking about here. It's very important that you guys cancel out factors and not terms. So in your first example where it says, yes, you can cancel these, that's because it's x times x plus 4. X is a factor, x plus 4 is a factor, because those are the two things being multiplied together. It's not x 4. X plus 4 is together. It needs to stay as one factor. So the only thing that would cancel here are the x's, and you would be left with x plus 4. So what I don't want you guys to do is cancel out what you see here in this second example, 2x plus 5 over 2x. 2x plus 5, because of that addition sign, this is not 2x times 5. If that were the case, it would cancel. But because 2x plus 5 is being added, it's its own sort of entity. It's its own thing. So you can't just cancel out part of that 2x plus 5 with the 2x below. So cancel out things that multiply together, not just common terms. So what we're going to do is factor our expressions, and then whatever is the same that equals 1, you can cancel out. So we're going to use our factoring practice with the diamond. So if you look at number 1, if we're trying to factor the top, we need to try to remember what multiplies to get you 15, but adds to get you negative 2 for this top. So what does multiply to get you negative 15 and 2? Well, 3 and 5. If our bottom number is negative, the larger number is negative. So the top will become x minus 5 and x plus 3. So this is the same as this, just written differently. We now have it factored. This was in standard form. The same expression though. If you multiplied it out, you should end up with x squared minus 2x minus 15. So if we do the bottom, x squared minus 9, you guys can put that 0x term in there if you want, if that's helpful. So we're trying to figure out what multiplies to get us negative 9, but adds to get us 0. So this would be negative 3 and positive 3. So what is the same in these expressions? The x plus 3 over x plus 3. itself divided by itself would be 1, cancels out, and we would just have x minus 5 over x minus 3. You can leave them in parentheses if you want. You don't have to, but that would be your fraction in simplest form. So we would do the same thing with number 2. You would factor the top and factor the bottom of that fraction and see what cancels.